The work towards the creation of the unit of length known as the meter was an illuminated endeavor. Founded in 1660 and granted the Royal Charter by King Charles II, the Royal Society started from groups of London physicians and natural philosophers. They were influenced by the leader of the Rosicrucian Masonic Order, Sir Francis Bacon, and his work, The New Atlantis. To this day, the Society advises the European Commission and the United States on matters of science. John Wilkins was one of the illuminated founders of the Royal Society. In his essay, Towards a Real Charter and Philosophical Language, Wilkins proposed a new universal language as well as a decimal system of measures. He proposed that the new length standard should be based on the pendulum. Some of his numerous written works include The Discovery of a World in the Moon, A Discourse Concerning a New Planet, Mercury, or the Secret and Swift Messenger, and Mathematical Magic. If a pendulum is displaced sideways from its resting or equilibrium position and then released, the restoring force due to gravity combined with the pendulum's mass causes it to swing back and forth. The time for one complete cycle, a left swing and a right swing, is called the period. The period depends on the pendulum's length and gravity's force. For small swings, the period is independent of amplitude. This property, called isosynchronism, is the reason pendulums are so useful in timekeeping. This is the equation for the oscillation of a simple pendulum. T is the time of one period, L is the length of the pendulum, and G is the acceleration of gravity. The Dutch mathematician, astronomer, physicist, and fellow member of the Society, Christian Huygens, had observed the length of such a pendulum to be 39.26 English inches, when taking 1 second per swing. No official action was taken toward the suggestion of a decimal measurement system by the Society at the time. In 1670, William Clement used the seconds pendulum, a pendulum length of slightly less than 1 meter, in his improved version of the original pendulum clock by Christian Huygens, creating the long case clock, which could tick 1 time each second. Until the early 20th century, long case or grandfather clocks were the world's most accurate. In 1675, Tito Livio Buraniti proposed that the length of the seconds pendulum be named the meter. A seconds pendulum is a pendulum whose period is precisely 2 seconds. 1 second for a swing in one direction and 1 second for the return swing, with a frequency of 1/2 Hertz. At standard gravity, or 9.806 meters per second squared, the seconds pendulum length is 0.99362 meters, or 39.1 inches. Experiments demonstrating the pendulum equation must be done in a vacuum to eliminate wind resistance, and the pendulum axis must be as frictionless as possible. The length of the meter used today is slightly longer than the length needed for a 2 seconds pendulum on Earth. This is why the value for L, the length of the pendulum, in the equation above is 0.993621 instead of 1 whole meter. In 1790, the French Bishop Charles Maurice de Talleyrand proposed that the meter be the length of a seconds pendulum at the latitude of 45 degrees, since it was known that gravity varied from the equator to the poles because of the centrifugal force of the Earth's rotation. Thomas Jefferson also considered this option, with 1/3 of this length defining the foot for redefining the yard in the United States, shortly after gaining independence. In 1791, with the anti-aristocracy spirit flourishing after the French Revolution, along with its rejection of the influence of the English Royal Society, the French Academy of Sciences defined the meter as equal to 1/10,000,000th of the distance between the North Pole and the equator. The seemingly arbitrary substitution required an accurate measurement of the meridian. The Academy commissioned an expedition to accurately measure the distance between a belfry in Dunkirk and Montjuïc Castle in Barcelona to estimate the length of the meridian arc through Dunkirk. This portion was assumed to be the same length as a Paris meridian, of Freemason esteem, since the Earth is not a perfect sphere and slightly bulges at the equator, nor is smooth on its surface. The prototype meter bar that resulted from the resulting measurement was 0.02% shorter than what it was originally proposed. However, the French standard was still adopted. This is the official explanation of why the meter is the length that it is today. However, there is an illuminated reason why this was done. The meter convention of 1875 constructed a prototype meter bar based on the distance between two lines on a standard bar composed of an alloy of 90% platinum and 10% iridium, measured at the temperature of 32 degrees Fahrenheit. After the Treaty of the Meter had been signed in 1875, the original Bureau of Weights and Measures made 31 prototype line standards of platinum, 10% iridium alloy. One bar was selected as the international meter. National prototype number 27 was sent to the United States and received by President Harrison on January 2, 1890. Number 27 became the U.S. reference standard for all length measurements. The international prototype meter remained the standard until 1960, when the 11th General Conference on Weights and Measures defined the meter as equal to 1,650,763.73 wavelengths of the orange-red emission line in the electromagnetic spectrum of the krypton 86 atom in a vacuum. Since 1983, the General Conference on Weights and Measures has defined the meter in a peculiar circular fashion as the length of the path traveled by light in a vacuum during the time interval of 1,299,792,458ths of a second. Stated differently, or circularly, light travels in 299,792,458 meters in 1 second. The Danish astronomer Olaus Rømer first successfully measured the speed of light based on observations of the eclipses of the moons of Jupiter in 1676. In part 1 of Pyramid Angels and the Speed of Light, I demonstrated how the angular measurement system of Earth was created in the context of the angelic and orbit precession ratio of the Earth. The ancients could see the secrets contained in the discernment of geometry. Plato said, "Geometry, rightly treated, is the knowledge of the eternal." It wasn't that the measurement system handed down to man coincidentally expressed such things as the value of the cycle of precession, but that the measurement system was created especially to mirror the very important physical laws and conditions of the Earth as it was physically set in the heavens. What if the value for the gravity on Earth was increased in the pendulum equation so that the value for the length of the pendulum came out exactly to 1 meter? As it turns out, Earth's standard gravity value only needs to be increased by 0.64195%. If the average gravity value on Earth's surface is increased by this value, then the pendulum equation would truly define the length of the meter used today. I'm sure many with some mathematical background might notice something peculiar about the g value in this equation. 9.869 is also known as pi squared. If the value for the acceleration of gravity on Earth is increased by 0.641% to pi squared in the pendulum equation, the length of the pendulum, the value L, becomes exactly 1 meter. In fact, the meter as it is defined today is defined by this equation, although nowhere you will find this information. Light travels at 299,792,458 units, known as meters, of the pendulum length defined by this equation each second. This equation cannot be thought of as arbitrary, nor can the fact that our meter just happens to be defined by it. It lends credence to the idea that the builders of the Great Pyramid did expect a length unit to be derived from the pendulum equation, to be used in turn to define the speed of light. The value for how far light travels in 1 second using the derived length unit would then be mirrored by the latitude value of the placement of the pyramid on Earth's surface. Remember that the modern definition of the meter is based circularly. That is, the speed of light is defined by how many meters it travels in 1 second, and the meter is defined by how far light travels in meters in 1 second. The 2-second pendulum at pi squared gravity is circular too, in the sense that it has a very circular theme. Pi square in radians is pi times pi radians around a circle. This graphically demonstrates the concept of a radian. An arc of a circle with the same length as the radius of that circle subtends an angle of 1 radian. The circumference subtends an angle of 2 pi radians. Pi times pi radians is equal to 565.48 degrees, or 1.57079 revolutions. The 1.57079 value is also an approximation for pi over 2. Interestingly, and on a side note, this 1.57 value, or pi over 2 value, is the same as the ratio of the distance of Mars and Earth from the Sun. Also, substituting the value of g in the pendulum equation with the gravity on Mars, but still using 1 meter for the length, changes the time for 1 swing cycle to 3.2 seconds. To see more about the importance of the 32 as it relates to Mars, see my video, The Fahrenheit Temperature Scale is Martian. The ramifications of all this are profound. The time increments used on Earth, hours, minutes, and seconds, also come from the same base 360-degree system of measurement given to Earth. If this was not the case, the pendulum equation could not express the speed of light in unit lengths equal to the value of the decimal degree latitude of the Great Pyramid. The meter necessarily had to be the length that it is, so that on Earth it would fit the pendulum equation using pi squared for g. It is only here on Earth that the unit of length that we call the meter could be defined, since the Earth's gravity approximates pi squared, and our angular measurement system uses 360 degrees. On a planet with greater or less gravity than Earth, the unit length to achieve the same pendulum cycle time would be too long or too short, and thus the speed of light in these units would not match the angular position of 29.9792458 degrees north. The Great Pyramid was not built by Egyptians, but by the same intelligence that inspired the measuring system in use today. They knew that the pyramid's existence in the future would reveal and illustrate these concepts.